Sunday, July 19th, 2026. 80,000 people will pack into a stadium in the New Jersey swamps to watch soccer decide a world champion. Hundreds of millions more will watch from everywhere else on Earth. Almost none of them will know that the ground under their seats already killed a building once. Before the turf, before the trophy, before a single ticket sold, there was a different stadium standing on this exact reclaimed marsh, a concrete monster that swallowed 13,500 tons of structural steel and 29,200 tons of poured concrete just to stand upright, close to double the iron content of the Eiffel Tower, raised by cranes that today's OSHA inspectors would shut a job site down for using. It took 4 years to build. It stood for 34 more, and it very nearly took pieces of the men who built it along with it. So how does a building end up burying its own secret for 34 years? What does it actually take to raise 80,000 seats out of a swamp? And what was sitting inside the walls the whole time that nobody, not the players, not the fans, not even a visiting pope, ever knew was there? Picture it going up first. Cranes swinging steel over open scaffolding with no safety net underneath. Concrete pumps running around the clock, while men balanced above a bog that used to swallow hunting blinds whole. No modern fall arrest gear. No 40 years of tightened regulation standing between a man and a 100-foot drop. Just a length of cable, a hard hat, and whatever nerve you brought to work that morning. Now picture it coming down. Excavators fitted with hydraulic shears strong enough to bite through reinforced concrete the way a dog bites through a bone. A machine built specifically because the demolition crew couldn't blow the thing up. Their new stadium was standing 30 yards away, close enough to touch. And when those shears finally cracked the old building's walls open, they didn't just find rust and dust and 40-year-old rebar. They found more than 1 million square feet of asbestos, sealed inside that concrete for 34 years, waiting for someone to disturb it. This is the story of the machines that built this ground, the machines that ran on it for 3.5 decades, and the machines that finally tore it apart, and of the men who stood close enough to all 3 sets of machines to get crushed, buried, or poisoned doing it. 3 different sets of machines, 3 different eras of danger. One patch of reclaimed swamp that never once, in 50+ years, stopped being hazardous to the men standing on it. Stick with this one to the end, because what's sitting under the field where they'll lift the World Cup trophy this Sunday is not what you think it is. The numbers nobody puts on a plaque. Start with the ground itself, because the ground was already trying to kill this project before a single crane showed up. The site sat inside the Hackensack Meadowlands, a belt of tidal marsh where, by the middle of the last century, more than 80% of the original wetland had already been dredged, filled, or dumped on. Crews had to pump and truck in enough fill material to raise and stabilize 750 acres of bog before anyone could even think about pouring a foundation. You do not build a stadium on a swamp. You build a swamp into something that can hold a stadium, and that fight alone 8 years. Before the steel, though, sit with this. So what actually kept 80,000 people moving through this building safely, tier after tier, for 3 straight decades? 4 separate spiral concrete ramps, 1 at each gate, carried the entire crowd up and down through the stadium's tiers, each one cast as a continuous, 2-way sloped slab of concrete, rising through the building like a coiled spring. No elevators for 80,000 people. No escalators built to handle that kind of load reliably. Not for very long, anyway. Just raw poured concrete, spiraling upward, engineered to carry the full weight of a sold-out crowd moving at once. We'll come back to exactly what it took to tear one of those ramps back down. It's not a small job. Now put that steel tonnage from the top of this video in real context. It went up around a structure 756 feet long and 592 feet wide. A building tall enough that its south tower cleared 178 feet, with a seating bowl rising 144 feet on its own. That same concrete total from the hook got poured to hold all that steel in place. The finished structure enclosed 64.5 million cubic feet of open air. None of those numbers mean much until you put a man in the middle of them, dangling off an aerial basket at height, with a country's worth of steel swinging past his shoulder. Here's the one that should stop you cold. 1972, the year ground broke on this project, sits almost dead center in the exact 3 years when American asbestos consumption peaked. North of 800,000 tons burned through the economy in a single year, most of it going straight into buildings, just like this one. The federal government had banned spray-applied asbestos fireproofing the year before construction wrapped. That means for most of the years this stadium was going up, that ban either didn't exist yet or had barely taken effect. So what did that actually mean for the men standing on this site while it was happening? Hold on to that question. It comes back. And here's the one that should really unsettle you. When demolition crews finally cracked this building open in 2010, 34 years after it opened, they didn't find a clean concrete shell. They found split slab mastic, floor tile, roofing material, and insulation. Over 1 million square feet of it. More surface area than 17 football fields laid side by side. All confirmed, tested, documented asbestos-containing material. Sitting inside a public building that 70 million people had walked through over its lifetime. A stadium that hosted Super Bowls. A stadium that hosted a pope. Underneath all of it, a hazardous materials site that took a specialized crew a full month, working multiple shifts, 6 days a week, just to strip clean before conventional demolition machines were even allowed near it. One more, before we go back to the beginning. This building's official capacity topped out at 80,242 seats. It broke its own record twice. Once for a World Cup qualifier that drew soccer fans by the tens of thousands, and again on its second-to-last weekend of existence, when a rock band closed out a farewell run to a crowd of 84,467, the single largest gathering the building ever held. A stadium designed in the early 70s to hold roughly 76,000 people at kickoff was, by its final year, routinely cracking 80,000 and beyond. More weight, more vibration, more decades of stress on concrete that was never engineered for a modern audience's numbers. We are going to explain how all of that happened, why a project built on marsh, powered by cranes with no modern safeguards, sealed a small chemical war inside its own walls before it ever hosted a single football game. And we're going to walk you right up to the morning in 2010, when a machine with a claw finally tore that secret back open, 30 yards from the new stadium, where, this Sunday, the world is about to watch a championship be decided. Built on ground that used to swallow things. The fight for this stadium started before anyone poured a single yard of concrete, and the fight was with the ground itself. On August 27, 1971, the New York Giants signed a 30-year lease to move into a stadium that, at the time, existed only on paper. The state stood up the New Jersey Sports and Exposition Authority to finance, build, and run the thing. No public money, bonds backed against future racetrack revenue instead. Groundbreaking came on November 19, 1972. George A. Fuller Company took the job as general contractor, working off designs from 3 separate architecture and engineering firms, Kivett and Myers, Ewing Cole Erdman and Eubank, and Klaus and Nolan, stitched together into one stadium. 3 design offices, 1 job site, and every disagreement between their drawings had to get resolved on paper before a crane ever lifted a single beam based on it. But before Fuller's crews could erect a single steel column, someone had to solve the marsh. The Hackensack Meadowlands is tidal wetland, soft, waterlogged, the kind of ground that swallows things and doesn't give them back. Crews dredged and filled roughly 750 acres of it, hauling in material to raise the site high enough to keep a stadium standing above the floodline. Every foot of elevation under that future end zone had to be trucked or pumped in by hand and machine, load after load, before the real construction could start. The whole project ran $78 million, north of $400 million in today's money, financed entirely through bonds backed against future racetrack betting revenue, without a cent of direct taxpayer funding. That financing structure meant the marsh had to cooperate on a schedule. Every month the fill crews spent fighting soft ground was a month the bonds were accruing interest against a stadium that didn't exist yet. That delay cost the Giants 3 seasons of homelessness. They spent 1973 and 74 playing 12 games at Yale Bowl in New Haven, Connecticut, and won exactly one of them, 1975. They squeezed into Shea Stadium in Queens, sharing a locker room circuit with the Jets, the Mets, and the Yankees. The stadium they'd signed a 30-year lease for wasn't ready until October 10, 1976, 5 weeks into that season. A team spent 3 years as tenants in other people's houses, waiting on a building that a swamp kept fighting them for. The marsh left its own folklore behind too, and it's worth mentioning because it tells you exactly what kind of ground this was. For decades, rumor held that Jimmy Hoffa, the Teamsters boss who vanished in 1975 and was never found, got buried somewhere inside this stadium's foundation while the concrete was still wet. Investigators searched. Nobody ever found a body, and most serious accounts treat the story as pure legend, not fact. But the legend stuck for a reason. This was ground that had spent decades as a dumping site for the region. Illegal fill, industrial runoff, garbage barges, waste that organized crime networks used the marsh to bury for cash. A stadium that could plausibly hide a body in its own foundation, in the public imagination at least, was standing on ground that had already swallowed plenty of things nobody wanted found. That legend sits on top of a well-documented, much less glamorous reality. Did organized crime really bury a body in this stadium's wet concrete? Nobody has ever proven it. But something else really was buried in this ground for decades, and this time it's fully on the record. For decades before the authority ever broke ground here, private contractors used sections of the wider meadowlands as an unofficial dumping ground, and organized crime networks controlled a significant share of that dumping trade. Waste that wasn't legally permitted anywhere else got trucked into the marsh anyway, sometimes leaving behind runoff the color of antifreeze running through the reeds. Underground fires smoldered in refuse piles across the wider basin for years at a stretch, and methane from decades of buried garbage still gets captured and burned off at landfills near the sports complex today, more than 50 years after the stadium's own groundbreaking. This is the character of the ground the New Jersey Sports and Exposition Authority had to tame before a single crane could safely operate on it. Not just wet and unstable, but sitting inside a region with a documented history of exactly the kind of quiet, illegal contamination that makes marshland dangerous to build on. There's a version of this land from before any of that. A local tradesman named Brian Moran, who'd end up working 3 separate projects on this exact patch of ground across 4 decades, remembered it from childhood. It was all marsh, he'd say later, describing hunting there with his family as a 10-year-old, launching canoes from a spot that would one day sit under a strip club parking lot, decades before either stadium existed. That's the last quiet version of this ground anyone would ever get. Everything after this point is concrete, steel, and machines. The stadium was never the only machine-driven project tearing up this marsh at once either. Construction crews were raising the Meadowlands racetrack on an adjacent stretch of the same reclaimed ground at the exact same time, and 5 years after the football stadium opened, a third venue, an indoor arena for basketball and hockey, went up practically next door. 3 major structures, 3 separate fleets of cranes and earth movers, all working the same drained swamp within a single decade. This ground didn't get one dangerous construction project. It got an entire industrial campus built on top of tidal marsh, one machine crew after another, for the better part of 10 straight years. 13,000 tons of steel, 0 room for error. Here's how you actually build a stadium bowl in the early 1970s, and it's not the way you'd guess. You don't pour it in place, section by section. like a driveway. You cast the pieces somewhere else first. Precast concrete risers, raker beams, columns, ramps, and then you fly each piece in with a crane and stack it like a puzzle that has to line up to the inch, 70,000 times over. High Concrete Group supplied the precast for this project, the same firm that would come back 35 years later to supply precast for its replacement. That's how specialized this work was. The same company got the call twice, decades apart, because almost nobody else could do it at this scale. The advantage of building this way was speed and strength. Precast members come out of the yard already cured, already tested, ready to carry load the moment they're set. The cost of building this way was that every single lift was a controlled catastrophe waiting to happen. A raker beam weighing tens of thousands of pounds, swinging on a cable above a crew's heads, has to be guided into a slot with tolerances measured in inches. Get the rigging wrong, get a wind gust at the wrong second, get a signal crossed between the crane operator and the ground crew, and that beam stops being a piece of a stadium and starts being a wrecking ball with a crane attached to it. That same steel tonnage from the top of this video went up around and through all that precast concrete. Beams, columns, connective steel threading the whole skeleton together so the finished bowl could carry 80,000 screaming bodies without so much as a shiver, all of it locked into place by the concrete total from the hook. To put that steel tonnage in real terms, that's roughly the weight of 30 fully loaded oil tankers, hoisted piece by piece, hundreds of feet in the air, by cranes that a modern rigger would consider dangerously under-equipped by today's safety standards. Walk the chain of it. A precast raker beam gets trucked in from the casting yard, still cool from curing. Riggers hook 4 cables to 4 lift points, and a signalman on the ground reads hand signals back to a crane operator who can't see the load directly. He's watching the beam swing past a steel skeleton with feet, sometimes inches, of clearance on either side. The crane lifts, swings, and lowers that beam into a connection point that has to seat correctly on the first try, because setting it down wrong and re-rigging a load that size mid-air is its own separate hazard. Multiply that single sequence by roughly 70,000 precast pieces, gate after gate, month after month, and you start to understand why stadium construction of this era treated the crane crew as the most dangerous job on site. Full stop. More dangerous than the concrete pours, more dangerous than the steel connections, because every other trade on the ground was, at some point in the shift, standing underneath a suspended load somebody else was controlling. The concrete work carried its own quieter danger. 29,200 tons of it had to go somewhere, and a structural pour can't stop halfway through without risking a cold joint, a weak seam where old concrete meets new and never fully bonds. That meant continuous pours running for hours at a stretch, batch trucks rotating in and out on a schedule with no room for delay, crews working the same wet concrete for as long as the pour demanded, whatever the weather happened to be doing over an open marsh that time of year. Rain didn't stop a scheduled pour. Cold didn't stop it either, not without risking the concrete curing wrong. The men finishing that surface worked exactly as long as the job needed them to. And remember that number we asked you to hold on to. 1972 through 1976. This stadium's entire construction window sits inside the exact years American asbestos use peaked, and inside the narrow window when federal regulation of it was still being written in real time. The Environmental Protection Agency banned spray-applied asbestos fireproofing the year before this stadium opened. The Occupational Safety and Health Administration itself was barely 2 years old when groundbreaking happened here, an agency still writing its very first construction standards, in an industry where, nationally, an average of 38 workers were dying on the job every single day. Steel erection rules that today prevent an estimated 30 fatalities a year in this trade specifically didn't exist yet. Nobody on this site in 1972 was working under anything close to the protections a steelworker gets today. Who ran these machines mattered as much as the machines themselves. Iron workers connecting steel at height, riggers slinging multi-ton precast loads, crane operators threading beams through gaps built for exactly one pass. This was skilled trade work, learned largely on the job and passed down crew to crew, because formal crane operator certification barely existed anywhere in the country at the time. A handful of major cities required it. Most of the nation, including this stretch of New Jersey marsh, did not. A man's qualification to run a crane carrying tens of thousands of pounds over another man's head often came down to how many years he'd spent doing it, not a license proving he'd been tested on it. So what happens when the only thing standing between a suspended load and the crew underneath it is one operator's word that he's done this before? None of that tells you why, 34 years later, a demolition crew would need a full month and specialized abatement teams just to make this building safe enough to knock down. That part of the story is still ahead. What it does tell you is this: everything about how this stadium went up, the swamp under it, the tonnage above it, the regulatory vacuum around it, was built to leave something behind. The question was only ever what, and who'd be standing closest when it came back out. The men who lived inside the machine. A stadium this size doesn't run itself once the ribbon's cut, and it doesn't finish getting built in one clean push either. For 34 years, this building needed men inside it constantly. Renovation crews patching aging concrete, maintenance teams fighting corrosion nobody could see from the stands, tradesmen threading new systems through walls poured back when Nixon was president. Concrete doesn't age gracefully in a coastal marsh. Salt air, freeze-thaw cycles, decades of vibration from 80,000 stomping feet. All of it works on rebar and cracks the shell around it from the inside, slowly, the way rust works on a ship nobody dry docks. Brian Moran spent 50 years as a sheet metal worker, and across those 5 decades he crossed paths with this ground 3 separate times. He worked renovations on the original Giants Stadium. He worked the construction of its replacement, going up right alongside it. And he worked the ski slope on the Xanadu development, another project that rose and fell in the same swamp. 3 different projects, 4 decades, 1 patch of reclaimed marsh. Men like Moran are the actual infrastructure of a site like this. Not the concrete, not the steel, but the tradesmen who keep coming back because the work keeps coming back, generation after generation, into the same ground. The daily reality for a crew working inside an aging stadium is not glamorous, and it is not safe by default. It's exposed rebar, where concrete has spalled away. It's working decks with no guardrail, because the guardrail hasn't been installed yet on this phase. It's dust, concrete dust, rust particulate, and, in a building built in the early 70s, potentially worse than dust, depending on which wall you're cutting into and whether anyone updated the hazard survey since the last renovation. Crews doing patch and repair work on an aging structure are, by definition, disturbing materials that were sealed up decades earlier and never meant to be opened again. The specific maintenance nightmares of a marsh-built concrete stadium are their own kind of relentless. Expansion joints designed to let the structure breathe through freeze and thaw eventually crack and let water in behind them. Waterproofing membranes fail quietly, one winter at a time, until rebar starts corroding from the inside and the concrete around it begins to spall, chunks calving off overhead walkways with no warning at all. None of that is dramatic on its own. It's just steady, grinding decay, and somebody has to climb up there and fix it every single year, for 34 years running, on a structure that keeps trying to fall apart around them while they work. Most of that work happened in the dead months, too. The narrow window between the last game of one football season and the first preseason event of the next, when maintenance crews had a matter of weeks to get major repairs done on a schedule that didn't care whether the weather cooperated. Cold concrete work in a January wind off the Meadowlands, running against a hard deadline set by a football calendar nobody was willing to move. That's the rhythm this building's caretakers lived on for 3.5 decades. Short windows, hard deadlines, and a structure that never stopped needing them. Here's a mini loop worth sitting with. How do you keep a 50-year-old stadium standing through 3.5 decades of hard use? You send crews back in, again and again, to fight corrosion nobody in the stands ever sees. But how do those crews know what they're cutting into when they open up a wall poured in 1974? Sometimes they don't, not until the material's already airborne. That's not a hypothetical for this building specifically. That's the standing reality of maintaining any large structure built during America's asbestos peak. And it's exactly the reality this stadium's maintenance crews worked inside for 34 straight years. The decay wasn't hidden either, not by the end. On December 29, 2007, an escalator at Gate A sped up without warning, then stopped dead, throwing fans down its own steel steps, hard enough that several stairs bent and tore open beneath the weight. 7 people were hurt that night. Broken bones, torn ligaments, and further legal proceedings involving the incident would later detail even more severe harm, including an amputation, among those caught in the mechanism. Those were fans, not construction crews, but the failure told you everything about where the building itself stood. A structure is not supposed to eat its own hardware 31 years into its life. Corrosion in the substructure, decades of vibration loosening bolted connections, salt air off the marsh working steadily on anything exposed. This is what a stadium sounds like when it's failing from the inside, long before anyone brings in a wrecking crew to finish the job on purpose. So how much longer could a building like this keep failing quietly before something finally came for it on purpose? By the time this building's final football game kicked off, January 3, 2010, Jets hosting the Bengals, it had hosted more than 1,600 events and put more than 70 million people through its turnstiles. Concerts, papal masses, 2 decades of professional soccer, including 7 matches during the actual 1994 World Cup, the last time the men's tournament touched American soil before this summer. Among them, a semi-final between Italy and Bulgaria that Italy won 2-1 on its way to the final. 32 years before this Sunday's championship, this exact ground already hosted one of the biggest matches world soccer had to offer. All of it happened inside a building that a much smaller number of tradesmen had spent 34 years quietly, dangerously keeping upright. A month after that final football game, the men keeping it upright switched jobs entirely. Their new assignment was tearing it back down. The day they finally cracked it open. It's February the 4th, 2010. You're standing on the frontage road outside Gate B, and the cold coming off the meadowlands cuts straight through a work jacket. A crane operator eases a boom into position, a hydraulic claw hanging off the end of it, like something built for a different, angrier job than construction. The claw closes on the concrete helix, the spiral ramp fans used to climb toward the upper deck for 34 years, and it doesn't push through the concrete so much as chew it. Rebar tears loose in long, screaming strands. Dust rolls off the wound in a cloud that hangs in the cold air longer than it should. About a dozen construction workers from the stadium next door, the brand new one, standing close enough that you could throw a football into its upper deck from here, climb up onto an open landing to watch. Some of them take pictures on cell phones. There's exactly one person watching who isn't press, isn't a construction worker, isn't a demolition crewman. It's Brian Moran, the sheet metal worker, sidelined that week with a broken foot, standing on the ground he hunted as a boy 40 years earlier. Ground he'd already told a reporter he barely recognized anymore. Somewhere behind him, the claw takes another bite. Vincent Parziale runs Gramercy, the wrecking and environmental contractor that won this job. A company that had already cut its teeth on an 18-story hospital tower and a 4-year asbestos removal project at a former cable manufacturing plant in Yonkers before this stadium ever came up for bid. Parziale's crews faced a problem most demolition jobs never have to solve. You cannot implode this building. The replacement stadium stands 30 yards away, close enough that a controlled collapse could damage a facility that just cost over $1 billion to build. So instead of one dramatic bang, Gramercy's plan calls for 4 months of mechanical demolition, tearing the building down in sections, from high to low, gate by gate, with more than 100 employees working the site at once. There is no emotion, Parziale says, of watching a stadium he loved as a fan come apart under his own company's machines. But before a single excavator could touch the structural bones of this building, somebody had to deal with what was hiding inside the walls. So what does it actually take to make a building safe enough to destroy? Abatement crews moved in first, working multiple shifts, 6 days a week, stripping out the same asbestos-containing material we flagged back at the start. The mastic under the flooring, the old roofing, the insulation packed behind decades of walls, all of it sealed inside this building since 1976. Over 1 million square feet of confirmed asbestos-containing material came out of this building in that first month alone, the exact number we told you to remember back at the start. That's not an estimate. That's the documented scope of what 34 years of this stadium's existence had been quietly holding inside its own walls, waiting for a crew in respirators to finally cut it loose. Think about what that actually looks like on the ground. A crew suits up before sunrise, zips into a decon chamber, and spends the next 8 to 10 hours working inside sealed plastic containment, with visibility limited to whatever their respirator lens allows. They can't hear much over the negative air machines running constant suction through the space. They can't feel the outside temperature. Every piece of material they pull down gets bagged, labeled, and logged before it ever leaves the building, because federal and state environmental law tracks hazardous waste from the moment it's disturbed to the moment it's buried in a licensed facility. Then they strip out of their suits in reverse order, shower, and do it again the next shift, 6 days a week, for a full month straight. That's the unglamorous, unphotographed labor that had to happen before a single demolition photo of a crane and a claw ever made the news. Once the building was clean enough to touch, the mechanical demolition itself came with its own hazards. Unstable sections of concrete that could shear off unpredictably once their supporting steel was cut. Dust clouds thick enough to cut visibility across the work zone, and falling debris from height in a structure that was, by design, never meant to come apart this way. Gramercy's plan called for controlled pulls, cutting a section's structural steel connections in a specific sequence, then hauling the section down into the field area with cable and machine power rather than letting gravity make the decision. But what happens when that sequence goes wrong? Get that sequence wrong, and a multi-ton concrete section can fall in a direction nobody planned for, onto ground where 100+ workers are moving equipment every single day. Only once that abatement work finished could the real demolition begin, and even then, the machines had to get creative. Remember those 4 spiral concrete ramps from the start of this story, the ones that carried 80,000 fans up through the building on nothing but poured concrete for 34 years. The stadium's helical ramps were poured as 2-way sloped concrete slabs, cast so tall and so thick that standard demolition equipment couldn't reach the top of them. Crews had to bring in a specialized high-reach shear machine just to chew the helixes down to a height where conventional excavators could finish the job. A ramp built to carry the weight of a sold-out crowd, safely, for 3.5 decades, took a purpose-built machine just to defeat. That's the debt this story owed you back in the first minute, paid in full, 1 bite at a time. Once a section came down, a separate machine took over. A mobile jaw crusher parked right on site, chewing broken concrete and masonry down into aggregate small enough to reuse as backfill instead of hauling it to a landfill. That crusher ran for months, feeding off the same building the shears and claws were still tearing into overhead. 2 different machines working 2 different jobs a few hundred feet apart on the same wounded structure. Piece by piece, floor by floor, the building that swallowed 13,500 tons of steel to go up gave every ounce of it back. More than 60,000 cubic yards of crushed concrete and masonry, recycled on-site as backfill, poured straight back into the 14-foot hole where the playing field used to sit. The stadium didn't just come down. It ate its own grave and filled it in with itself. Full demolition, start to finish, wrapped by August 10, 2010. 6 months, 1,000+ workers cycling through the site across the project's life. And, based on every record available, not one fatality on the job. 6 months after that February morning, the site sat quiet for the first time in nearly 40 years. No crane engines idling, no claw biting into concrete. Just an open, leveled stretch of reclaimed marsh at dawn, the kind of empty, gray quiet the ground hadn't felt since before anyone broke it open for a foundation. Whatever birds still work this part of the meadowlands had the run of it again, at least for a season, before the next set of tenants moved in. What's sleeping under the World Cup final? Here's the part almost nobody watching this Sunday's final will know. The stadium hosting the 2026 World Cup final didn't replace Giants Stadium from a clean lot. It grew up right beside it, both buildings standing shoulder to shoulder for nearly 3 full years, while one finished going up and the other waited its turn to come down. Construction on the new stadium started in September 2007, using 2 Liebherr 1400 cranes and a Liebherr 1300 crane to raise 16,500 pieces of steel, weighing 24,000 tons, nearly double the tonnage of the building it was replacing, going up on soil packed with 5,200 concrete-filled steel pipe piles driven straight into that same reclaimed marsh. This time, the work went differently, not by accident. The project ran under a project labor agreement, written specifically to survive the kind of scrutiny nobody thought to apply back in 1972, and by the time the last piece of steel went up, the job had logged 4.5 million labor hours without a serious accident on record. That's not luck. That's what it looks like when an entire industry finally gets forced, one dead worker and one lawsuit at a time, into treating a construction site like the hazard it always was. So where did all that hard-won caution come from? Partly from a stadium standing 30 yards away that had already taught this industry every lesson the hard way. 40,000 tons of recycled steel went into the new build, half of it salvaged straight off the carcass of the old stadium next door. Engineers on the project put the total combined figure, steel and concrete recovered from Giants Stadium and folded into its replacement, at roughly 70,000 tons, with another 7,000 tons of debris diverted from landfills entirely. The new stadium is, quite literally, partly built out of the bones of the one the machines tore apart to make room for it. The new stadium outsizes its predecessor in almost every raw measure, 2.1 million square feet against the old building's footprint, more than 82,500 seats. None of that is the part worth sitting with. The part worth sitting with is that 445,000 square feet of the new structure is precast concrete, poured by the same company that supplied the original building's risers back in the 70s, which means some of the hands setting this stadium's bones had learned the trade on the one it buried. Sit with that for a second, because it's the quietest, strangest fact in this whole story. So where did all that recovered steel actually go? Somewhere inside the concrete of the stadium hosting a World Cup final this Sunday, there is steel that was once part of a building containing more than 1 million square feet of asbestos. Not the hazardous material itself. That got hauled off to licensed disposal sites under environmental law, tracked and documented the whole way. But the clean steel, the recyclable bones, poured back into a new structure standing on the exact ground its predecessor once occupied. Pieces of the old stadium got reborn, quietly, inside the concrete and steel of the building that replaced it. Before that Sunday match, take one quiet look at what this ground has actually hosted. 1994, this same patch of marsh watched World Cup matches under the old stadium's lights, the last time the men's tournament played on American soil. The old stadium kept hosting the sport almost right up to its final days, too. A scoreless draw, against the world's top-ranked team in 2008, a regional championship final in 2009 that packed in nearly 80,000 fans. This ground was already a soccer venue before its replacement ever got the chance to prove itself. 2026, 80,000 plus people will fill the new one to watch the tournament's biggest match yet, the first World Cup final on American ground since that year, expanded to 48 teams, the largest edition the sport has ever staged. The stadium carried 5 tournament group stage matches and multiple knockout round games before earning the final itself, and days before kickoff, it picked up a LEED Gold sustainability rating, a green badge stapled onto a stadium quietly built from the recycled remains of the one it buried. For the length of the tournament, FIFA's sponsorship rules strip the venue of its corporate name entirely. Broadcasters and signage call it New York, New Jersey Stadium instead, scrubbing the MetLife branding off a building that, underneath the temporary name, never stopped being the stadium built beside a poisoned one. 2 different buildings, 3.5 decades apart, both standing on ground that had to be dredged out of a swamp before either one could hold a single fan. Brian Moran's story closes here, on the same ground he opened it on. A boy who canoed this marsh at 10 years old grew into a man who spent 50 years working 3 different projects across it, repairing the first stadium, building the second one right alongside it, and standing on a broken foot to watch the first one finally come apart. He never got hurt by any of the machines this story followed, but that's not a happy ending. It's just the odds landing his way, on ground that spent half a century trying to hurt somebody. So what else is still sitting quietly under a stadium nobody thinks to ask about? This Sunday, when the ball kicks off and 80,000 voices go up at once, almost nobody in that crowd will know what's underneath them. They won't know about the swamp that had to be conquered before anyone could pour a foundation. They won't know about the men working under suspended steel with none of the protections a crew gets today. In the exact years this country burned through more asbestos than at any point before or since. They won't know that 1 million square feet of it sat sealed inside a public stadium for 34 years before a crew in respirators finally cut it loose, 6 days a week, 1 month straight, to make room for the very ground they're standing on now. Here's the number to leave you with, and it's a real one. In 1970, the year this whole story's regulatory clock started ticking, an estimated 38 workers died on the job somewhere in America every single day. By 2023, that number had fallen to 15. Still 15 too many. But the distance between those 2 figures is the entire distance this ground traveled, from a marsh where cranes swung uncertified loads over unprotected men, to a stadium built under a labor agreement that logged 4.5 million hours without a serious accident. Same ground, same industry, 50 years apart. The machines that built this place, the machines that ran it, and the machines that finally tore it apart, never stopped being dangerous, not for one single day across 50-plus years of history on this ground. The men who worked alongside those machines just kept showing up anyway, generation after generation, because the work was here and somebody had to do it. This Sunday, the world's biggest game gets played on ground that already buried one stadium. Most of the people watching will never know it. Now you do.